Welcome back to the video lecture series on statistics for machine learning. This is Amit Kumar Das, and we are going through the theory of probability. We have already seen the basic concepts of probability and the theorems related to probability. Now I'm going to cover another very important concept which is related to the theory of probability, right? And the concept is of the concept of random variables. Okay, so what is a random variable? We need to understand first. So we have already talked about random experiments, right? So random experiments have got outcomes and events attached to it, right? Now, all the random experiments may not have outcomes which can be represented by a number, right? So, say for example, I consider a space which basically represents all the numbers or the outcomes, sorry, the outcomes of the random experiments as one of the sample point, right? So this is one sample point, this is one sample point, this is one sample point. So there can be multiple sample points, which each of which represent a particular what should I say, outcome of the random experiment. Now, this whole thing, we can call it a sample space, right? So sample space is the whole thing, all possible outcomes being represented in the form of a sample space, and individual outcomes are represented as sample points. Now, each of these sample points may not have a specific number value attached to it, right? So, how do we do to convert it to a number value? We may use specific functions, right, to convert these outcomes into some specific number values. Okay, so these functions are known as the random variables. Okay, so random variables often represented as x. So let me take an example so that it's very clear for all of us. Let me take the example of the random experiment where two coins are being thrown. Okay, two coins are tossed. Okay, two coins. Now, what can be the sample points? The sample points can be either a head and a head. Okay, a head and a tail. Okay, a tail and a head, or it can be a tail and a tail. So this is when we have two coins. If we have three coins, there will be more such sample points like HHH, HHT, HTH, and so on and so forth, right? Now, all these are not numbers. This TT or TH, these are not numbers, right? So how can I convert this to a number? Say, for example, if I define a rule, okay, if I define a rule where the rule is like number of heads, number of heads, okay, or we have the rule as, say, square of the number of head minus the number of tail. Okay, so square of number of heads, okay, h count, count, and the tail count, the t count. Okay, this whole difference, that's squared. Okay, so like this, we can define a function like this. This is a function that difference of head, number of heads minus number of tails, square of it. Okay, so that way each of these points can be converted to a specific number. Say for example, here the number of head is 2 and the number of tail is 0. What will be the numerical value for this? So x, if x is the random variable here, right? Now the sample point e can be represented by that x of e, right? The number x of e. So if I say x of e, what is going to be the value of x of e? It is going to be 2 minus 0 square, which is equal to 4, right? This is equal to 4. Like this here, 1 minus 1, head and tail both are 1, so it's going to be equal to 0. Here it is going to be tail minus head, so again 1 minus 1, so again 0, and this is going to be number of heads is 0, number of tails is 0. So 0 minus 2 square. So that is also going to be 4. Now what we have, for each of the sample point, we have got a specific number. And how did we arrive at the number? By using some kind of a function. What is the function we have used here? Number of heads minus number of tails square. Okay, and that is the function we have used. This particular function, that number of head minus number of tail square, is known as random variable, and this is a very important perspective in the theory of probability. Let us take one more example. Okay, let us take the example of tossing of a not tossing of a coin, throwing of a die. Okay, so when we throw just one die, right? So what are the possible outcomes? The possible outcomes are either we have a 1, or we have a 2, or we have a 3, or we have a 4, or we have a 5, or we have a 6. Okay, now if I want to, and when I throw two dice, okay, so I can have a 1 1, I can have a 1 2, I can have a 1 3, I can have a 2 1, I can have a 2 2, 2 3, 2 4. Like this I can have different sample points. Okay, again, these are not really numbers, right? If I want to represent it by a number, again I have to use a random variable x. And when I use that random variable x and I use that on a particular point, sample point e, I get a value, integer value, which is xe. Okay, I get a value. Okay, now say for example I define a random variable. Say I throw two dice together. Okay, now when I throw two dice together and I define the random variable as sum of points, sum of points. This is the simple random variable. Okay, so what's going to be the values of xe in this case? The values of xe is going to be, say, when I have 1 from both the dice, so then the sum is going to be 2. When I have a 2 and the other one has a 1, so in that case it is a 3. When I have a 2 from the 2 from the first die and say 3 from the second die, then the total number of points is going to be 5. So like this I am going to have altogether how many points? I will have 36 points. Okay, so like this we can define different random variables x, and we can find corresponding to each of the sample point e, I can find a numeric value which is the value which you get by applying that random variable, which is a function, on the sample point e. Okay, so xe is that value. So when we come back in the next lecture, we are going to delve a little deeper into the random variables, and we are going to look at discrete random variables and a discrete probability distribution. So we are going to look at the concept of probability distribution. That's the first thing. And then we are going to look at a discrete probability distribution and a continuous probability distribution. These are very important concepts which we need to understand before we move forward. Okay, so stay tuned. Thank you very much.